Alright, welcome guys. Temperature and heat and also thermal expansion. Remember, we'll tackle all the theoretical questions. So, one has to do with calculation, two has to do with calculation. Every other question that has to do with calculation will be treated differently, will be solved differently. So, number three, in what range of temperature is the expansion of water anomalous? Anomalous behavior of water means, everybody writes, anomalous behavior of water means water contracts from 0 to 4 degrees, having its maximum density and its least volume. Now, anomalous behavior of water actually means that if you see something, if you put water inside a if you put water inside like a plastic bottle now, and you put it inside the freezer, it would start getting cold. And whenever an item is getting cold, it's supposed to contract, like it will shrink. It will contract, it will shrink, it will squeeze, become smaller. Now, but once water gets to 4 degree, instead for it to contract, it will start swelling up. And that's why sometimes that same bottle, similar thing, that's why like your Coca-Cola bottle and the rest, you don't put them in freezer. If they get to 4 degree, they would burst because they will start to swell up. So water, every other item, once you put them in a bottle, they would only contract, like they would shrink and become smaller and smaller and smaller. But water does the opposite. Maybe the water is 10 degrees, it will contract from 10, 9, 8, 7, 6, 5. When it gets to 4 degree, instead for it to contract, it will start to swell up. Do you understand? It will swell. It will be expanding. It will expand until 0 degree again before it will start shrinking again. So that behavior is called anomalous behavior of water. It's not normal. So the behavior happens from when to when. In physics, that behavior of water happens from, you could see it from 0 to 4 degree. Okay? So number 3 is option E. Hope you understand anomalous behavior of water now. Good. You could also create out a note out of that. Number 4 has to do with calculation. 5. Consider a thick glass tumbler and a thin glass tumbler which are made of the same kind of glass. Some hot liquid is poured into them. Which of the following statements is correct? Number 5 is clearly option D. The thick tumbler is more likely to crack because uneven expansion persists for a longer time within the thicker glass. Yes, the thick one would crack. Number 5, when you pour hot water into a glass bottle, one is thin, the other one is thick. The thick one is more likely to crack a bit. You might not even observe it, but it will crack. 6, in the study of physics, temperature and heat are often confused with each other. Which of the following statements correctly defines the both? Everybody write down. Temperature, number 6 is actually, let's see, I'm going to define it for you. Okay, look at the options. Okay, option A. First, everybody write down. Temperature is the temperature. Okay, so they start from here. Temperature and this thing continue. The definition continue, right? Number 6. So you could see, right? Temperature is a measure of the average kinetic energy of molecule of a substance. Next, right? Heat is the measure of the total kinetic energy of the molecule in a system. You get? So option A is the definition of temperature. Option B is the definition of heat. Option C now, different metal require different amount of heat to cause a given change in temperature, correct? Then option D, all of the above. Then option E, A and B only. The correct answer for number 6 is all of the above. You get? All of the above. Number 7 has to do with calculation. We'll skip 8. We'll skip 9. A liquid in glass thermometer should quickly register temperature changes. This is achieved by choosing a liquid that, this is only achieved when you pick a liquid that has a higher thermal conductivity. has a higher thermal conductivity. And a higher thermal conductivity means that the liquid will allow heat to pass through it quickly, which will show a shorter time in response. Example, if you don't ever go hospital, they won't check your temperature. That clinical thermometer they put in between your armpit, they will tell you close your hand. Notice after some time they will collect them from you. They will check your temperature. That item within inside probably na mercury, and mercury na one substance we we get high thermal conductivity. So any small heat it will affect mercury, and that's why inside there na mercury. So within the nurse or the doctor go read, no be your business for now. But that item they call clinical thermometer. So number 9 is option D. Number 10. Which of the following statement is not true? Thermostats are used to control the temperature of temperature of pressure cookers. 10A. Nah. Right. Pressure cookers work on the principle of the higher the temperature, the higher the pressure, the higher the temperature at which the liquid will boil. Pressure cookers work on the principle of the higher the pressure, the higher the temperature at which the liquid will boil. So number A is not true. But thermostat work on the other principle. Laundry iron, thermostat na one device where be say if something too hot, it go off. Just like your normal pressing iron they do. If you dey press clothes, when the thing heat reach a place, it go off. Abi no be so? If just like that thing thermostat inside the iron. You get am? So 10 is laundry irons. You also have aquaria for tropical fishes and also heated apartments. You know go feel, you might not know if you've been to like this European worlds like Canada or US, some part of the US where they get snow well. They get heater inside their rooms, even in the UK and the rest. So for winter, like Russia too, there's the heater go they regulate. It will make the room warm. Yeah, for Africa, they look for AC to make them cool every time. There, it's kind of the other way around. They go look for heater, we go make the room warm small. Then after some time, if it's heater notice say the room don't dey overhot, it go stop by himself. Wetin dey notice say the room dey overhot na thermostat. You get? Number 11 is skip, 12 is skip, 13. A short response in time is obtained in a liquid in glass thermometer when, remember, we touch similar thing. Now we say higher conductivity, higher thermal conductivity, abi, when, see, the bulb is thin walled and the liquid is a good conductor of heat. You see, liquid is a good conductor of heat, but also that item where you put in between your armpit to check your temperature, that glass they thin, they thick, or else the mercury no go quickly. Your temperature, no matter how high your temperature be, it don't go quickly. The mercury no go quickly fill am. So the bulb must be thin. That's what they mean there. 14. Skip that. Okay, 14 they say. Okay. 14 has a bit of this thing. Let's go through something. Which of the following statement clearly describes this one? To better understand 14 actually, but I'll pick the option. But to better understand it, I will need to demonstrate it. So which of the following statement clearly describes that the linear expansivity of copper and steel are this and this respectively. The bimetallic strip will not be able to close the circuit when there is fire. Behavior of the fire alarm. We'll come back to this in demonstrative video. 15 has been solved also. 16. Which of the following properties of matter cannot be utilized for temperature measurement? We cannot use it to measure temperature. Current producing a photoelectric effect. Option E. If you use the length of a liquid column to measure temperature, volume of a gas at constant pressure, if you use them, pressure of a gas at constant volume, if you use them, resistance of a metallic wire, you can use it to measure temperature, but if you use current producing photoelectric effect. 16 is option E. 17 calculation. 18 repeated question. Anomalous behavior of water. Water shows anomalous behavior below or behavior, then they put full stop there. 18 is option B. Between 0 and 4 degrees Celsius. 18, don't forget anomalous behavior. If you skip the video, go here and again. I use Pigeon Explainer. Everything, every liquid, if you put them inside freezer, they go they shrink, they shrink, they shrink. But water, it go shrink, shrink, shrink. If you reach 4 degrees, it go begin swell up. And that's why sometimes that your plastic can, before it go become a complete freezer, it go first swell up. If you don't observe them before. Now the same thing we make Coke they burst. All those items they go burst inside the bottle. You understand? Because they contain certain level of water. That's why they put Coke inside deep freezer. More run. The expansion of solid can be considered a disadvantage in balance wheel of a watch. Option A, 20. Has to do with calculation. 21. A metallic strip of iron and brass was heated. Which of the following diagram accurately illustrate the shape of the strip after heating? The one that accurately illustrates it is option B. Option B. Right. Brass expand longer than iron. Hence, you get a convex side. This side like this could be brass. This side where they form C like this could be brass. Because brass, they extend more than iron. Okay, they expand more. 22 calculation, 23. Similar thing. 24. Then 25. Now formula. I will pick the answer. A bar of initial length L0 is heated through a temperature change of the 30 to a new length L. The linear expansivity of the bar is this L1 minus L0 over L0 delta T. This one might be the correct formula to measure linear expansivity. 26 calculation, 27, 28, 29, 30. One of the most important application of bimetallic strip is found in the construction of bimetallic strip. An electric laundry, a thermostat, right? 30 is option A. So bimetallic strip, a thermostat. Now a thermostat, bimetallic strip inside the thermostat, and it helps in, like, remember I say thermostat, and they help regulate temperature for like laundry iron. That's why they call pressing iron. 31. The thermometric property of a thermocouple is that its EMF changes with temperature. 31 is option A. Change in potential difference between the two metallic junctions with temperature change. 31 is option A. 32, 33. The melting point of naphthalene is 78 degrees. What is it? Now that has to do with calculation. Let's run. 34. Temperature is the measure of the average kinetic energy. 34. Don't forget the temperature. Now the measure of the average kinetic energy. Temperature is option B. Mean or average kinetic energy of any molecule of an object. 34 is option B. 35. So the calculation. 36 calculation. 37. 38. 39. 40. 41. The diagram below shows a maximum and minimum thermometer divided into 3 portions, P, Q, and R. Which of the following is true about the respective content of P, Q, and R? 41 is theoretical. C, alcohol, mercury, and alcohol. P, Abi, this P part na alcohol there. This Q part na mercury. Then this R part na alcohol again. That's 41. 42. A quantity of water at 0 degree is heated to about 30 degrees. At each degree rise in temperature, its density will, 42 is, the density will rise then fall. Don't forget say water go behave anomalous from 0 to 4 degree. So water reaches, right, they used to ask this one, water reaches its maximum density at 4 degrees, you get, and its least volume. So maximum density at that 4 degrees and least volume. Alright. a thin wire with heavy. So see, when I go back to this question, so when they say water, so you heat the water from 4 to 30 degrees Celsius, what will happen? Don't forget, it go first swell up, then it will come down. You get. So 42, rise and fall. Option B. A thin wire with heavy weight attached to both ends is hung over a block of ice, resting on two supports. If the wire cuts through the ice block while the block remains solid behind the wire, the process is called regulation. Option D. If you try this thing out, get ice block, the one wey dem create for inside polythene bag or nylon bag. Remove the polythene bag, get a very thin wire. Use your both hands, press the wire across the ice block. The wire go dey cut in between. As e dey cut through the ice block, any part wey don cut through, the ice block go join again from there. When you do finish, you go discover say the ice block no go separate into two, and e dey call regulation. Regulation. 4. Water is a poor thermometric liquid because it is a poor conductor. Option C. 45. Thermal equilibrium between two objects exists when wait. Sorry. Water is a poor thermometric. That's 44, abi. 43 is option D. 44 is option C. Is a poor conductor. Okay. 44 is option C. 45. Thermal equilibrium between two objects exists when. 45 is option A. The temperature of both objects are equal. Option A. When they say something is at equilibrium, it means say don't balance. When I don't balance each other out. 47. When left in a freezer, a bottle of water, you see cracks on freezing into ice because. 47. Don't forget to increase the volume of water. You understand? So water go anomalous expansion of water. So everybody write this one for me. Anomalous expansion of water from 0 degree to 4 degree, water go contract. You get. Then from 4 degree to like 100 degree, it go expand. So write like that. So you go say 0 degree, put a line and put arrow. To 4 degree, water contract, while from 4 degree to 100 it expand. Now go down and write from 100 degree to 4 degree, water go contract. Then from 4 degree, put the arrow again, 4 degree to 0 degree, water go expand. You understand? Good. So if you dey cold water, you go first dey contract. If you reach 4 degree, you go begin swell up. That's why the bottle dey burst. Because you know say bottle no fit swell up follow this thing. Forgive me, I dey use swell up. I just want make you understand that well. 49. Reproducibility, sensitivity, high thermal capacity, high accuracy. The qualities of a good thermometer include, you go write them down. I'll pick the answer for you because of time. It include II and IV. Option B. So you go write down you go write qualities of a good thermometer. The correct answer to 49 is option B. More no waste time. If you go back, go list them out in your notes. You say qualities of a good qualities of a good thermometer. Put I, put II, put IV. You get them. 50. When very hot water is poured into two identical thin glass tumbler in equal volume, the thick one cracks, the thick one go crack. We don't first touch this one because uneven expansion of glass. 50 is option A. You're not supposed to pass A, but let's see if there's other options before you pick. Option C. Of even. See this one, they say of even, wrong. Uneven, I made the right answer. So even myself, I almost want to pick the wrong answer. Always read all options before you pick your answer. You get uneven expansion of glass. 51. What is likely to happen if the glass of a thermometer expand more upon heating than the liquid? What will happen? 51. The liquid will go down the stem. There's something called stem in the thermometer. If the glass expand more than the liquid inside, the liquid will just go down now. You get. 51 is option B. It's just like straw now. Straw we take the drink we take the drink uh maybe any soda or any minerals. If they expand the straw, what if you say go happen? All the liquid will just fall back into the bottle. If you expand the glass, the liquid will just go down the stem. 52. The thermometric property of a constant volume thermometer is 52. Right. The thermometer works on the principle of the fact that the pressure of a gas at a constant volume varies linearly with its temperature. So this one, 52, is option A, change in pressure. So constant volume works on the principle of change in pressure. 53 has to do with a bit of calculation. 54. 54. They say use a liquid with high melting point. Use a liquid of high volume expansivity II. Use a capillary tube of large diameter. Which of the above best describe how sensitivity of a liquid in gas can be enhanced? Use a liquid of, it's supposed to be II only. Option A, 54 is option A. II only. The other ones no go. How you go take no? Go back and check your note. I'll already tell you what is supposed to go. 56. A clinical thermometer is different from other mercury in glass thermometer owing to what makes it different? Owing to the constriction on its stem. 56 is option B. The constriction on its stem. 57. The thermometric property of a thermocouple is the change in electromotive force. 57 is electromotive force. 58. During summer, the balance wheel of a clock expands. What effect does this have on the accuracy of the clock? What effect does it have on the accuracy of the clock? The clock will lose time. 58. The clock will lose time. 59. The thermometer whose reading is indicated by a change in color of its thermometric property is the optical pyrometer. 59 is option D. Optical pyrometer. Optical pyrometer. Everybody write down. Bimetallic strip thermometer works on the principle of differential expansion of two metals in the strip. Next, right? Resistance thermometer works on the principle of changing electrical resistance with temperature. Number 3. Gas volume thermometer works on the principle of pressure. Then lastly, liquid in glass thermometer works on the principle of change in the volume of the liquid with temperature. Full stop. Hope you wrote those things down. So 59 is option D. 60. At 4 degrees, the volume of a fixed mass of water is, see this question, is max. Is they say minimum and it's maximum. It's maximum. Sorry, it has minimum. They say at 4 degrees, okay? At 4 degrees, the volume of a fixed mass of water is, go back to that chart I gave you, when it's going from 0 to 4, and when it's going from 4 to this thing. What will happen? The volume will be, the volume is minimum, then the density is max. Is option A. 61. One special advantage of alcohol over mercury as a thermometric liquid is that alcohol has a low freezing point. Alcohol no dey quick freeze, right? Alcohol has a melting point of minus 115 degree. Hence, can be used to measure very, very low temperature. While mercury has a melting point of minus 39 degrees Celsius. So 61 is option A. 62 calculation. 63, I'll just pick the 63 option. The reason why, we've touched it before: high thermal capacity, high sensitivity, easy readability, accuracy over wide range of temperature. 63 is option B. I, and IV. They say to get a good, from the statement above, the qualities of a good thermometer are dependent on option B. 63 is option B. Option B. 64. Clinical thermometers are examples of mercury in glass thermometer. 65 option D. 66 has to do with calculation, so we'll run. 66 has to do with calculation. 66. Okay, the question will actually stop at 71. 66. Okay. 67 calculation, 68 calculation, 9, 70. Which of the following is not an application of expansion in meta? It's not an application of an expansion in meta. Sagging of wire, sagging of telegraph wire, option D, sagging of telegraph wire. Now, we've been able to come to the end of this chapter. If you've gotten to this point, the little note you've been able to jot down, I want you to snap the note and send to us on the WhatsApp group. If you are yet to be on the WhatsApp group and this is your first time of coming across any of our clip and you want to, we run classes to help you prepare for your next exams. If you want to be part of the class, I'll also leave the link to the WhatsApp group in the description box. You could click on the link and join us and enroll. Thanks for watching. I'll see you in the next video. Thanks for practicing with me.